The growing number of cars in countries such as China, where it has grown by 210% in the last decade alone, has led to a significant increase in the number of end-of-life vehicles, also known as ELVs. ELVs are motor vehicles that are categorized as waste that are sent to be discarded, in compliance with Sustainable Development Goal 12, proposed by the United Nations, where it is defined as ensuring sustainable consumption and production patterns. It is an engineer's responsibility to ensure that these ELVs are recycled properly. In this video, we will be presenting how life cycle assessment, also known as LCA, can be used to evaluate different levels of ELV recycling in China and its effects on the environment. The functional unit chosen for this LCA study is a Toyota Corolla, as it is the most sold car in the world. The system boundary is taken to be gate to gate, where only the recycling process of the car, including the transportation of the car and waste, would be considered. The three levels of ELV recycling are: Scenario 1, where acetylene cutting is used in dismantling, and only metals and oils were recycled, with the plastic, glass and other metals regarded as waste. Scenario 2, where semi-automatic shearing machine and packer machine that uses electricity was instead used for dismantling. Additionally, chlorofluorocarbon, CFC, and waste liquid were recovered, and the engine was remanufactured. Scenario 3 follows on from Scenario 2, with the addition of magnetic separation to separate ferrous metals from non-ferrous metals, and shredder residue. The shredder residue was then further recycled to produce plastics. The following are the normalized results of the impact assessment. 6 impact categories were chosen, which include abiotic depletion potential, ADP, acidification potential, AP, eutrophication potential, EP, global warming potential, GWP, human toxicity potential, HTP, and photochemical ozone creation potential, POCP. As these indicated actual environmental problems in China, it was observed that Scenario 1 recycling had negative impacts on the environment in the global warming, eutrophication, and photochemical smog categories, whilst Scenarios 2 and 3 had positive environmental impacts for all categories. Thus, this LCA study proved that current manual dismantling recycling should be replaced by advanced recycling methods for greater sustainability. Taking the materials obtained from Scenario 3 recycling as reference, the potential use of these recycled materials to further align with SDG 12 was analyzed for each part of the car. Rubber from waste tires can be sent to a pyrolysis plant to produce fuel oils and carbon black. Metals such as aluminum can be recycled to produce drink cans, windows and shingles. Waste windscreen and window glasses can be used to produce glasswares. Recycled plastics such as polyethylene and polypropylene can be used to produce housewares such as containers and furnitures. Scrap copper from engines, brake pads and bearings can be used to produce copper wires in large scale. And that's the life cycle assessment of an end-of-life vehicle.